We have four linear equations here in the assignment for the weekend. Solving linear equations, and you know, we've done this, but we didn't do it exactly as it is. We're just trying to assess things, because people seem to be pretty good with the homework that was due today. We want to do these very systematically so that we can see clearly what each step is, and we want to document each step so we know what we're doing, okay? And so that we can easily check if we make a mistake. Now, you notice that I never make mistakes, so I don't really need to check, but yeah, you all might sometime make a mistake. And sometimes, of course, I pretend to make a mistake, just so you can see what it's like to make a mistake and then go back and fix it. Okay? Got it? That is the official line. All this spontaneously because I just think it does a better job. Okay. I'm standing here copying a solution that I've already done. I lose every bit of my fall asleep. Equals 3. Now, what people are traditionally taught to do subtract 7 from both sides, because if these two things are equal, then these two things have to be equal, because the only difference is I've subtracted 7 both sides. So if they're in balance and I take 7 away from this one and 7 away from this one, they'll still be balanced. Okay. And in that case, you get 2x because 7 minus 7 is 0. And if you add 0 to 2x, you've got 2x, right? And 3 minus and then we check. We take this -2. -2 plus 7, it better equal 3. Well, we do the arithmetic, we get -4 plus 7 equals 3. We get 3 equals 3, and it checks. Right? Mention right now, you're not going to see it, I don't think, in the assignments. And we are just getting to the point in pre-calculus where we're going to start graphing these things. Okay. If x equals, we graph. Zero 7. If y equals three is about here. Here's y equals 3. Here's the point where y equals 3. And right there is the value of x. It makes this true. And we see that according to this is -3.5. That might be -3, but probably like negative 2.5. So from a graph, we can estimate what x ought to be. So this is reasonable that the x ought to equal negative 2.5, where the y equals 3 line meets the graph of the straight line. And that's not an absolute check, because if you substitute negative 2.5 in here, it doesn't quite work out. Okay, I think you get 2 equals 3 when you come down here. You do that, but it's close. So it means that makes it more likely if this is a solution. Okay, so you have graphical methods of estimating solutions, but we have the algebraic method of getting the exact solution. There's an important point there. Again, we'll do more with this, and we've already done a lot with this in the pre-calculus class, estimating solutions. So we haven't even talked about that in pre-calculus. Okay, but we're getting there. Okay. Now, the other way this is often written out. Put a minus 7, 10. You guys told you about that in pre-calculus? Yeah, not every section will. It's coming up in pre-calculus. Yeah, plus it's now mathematically valid. Negative 4, sorry. Percent. Like this, or you can do it like tackle this equation. Just enough room, I think, to work that one. First thing I do is I use the distributive law. 3 times the quantity 4x minus 2 is 3 times 4x minus 3 times 2. The 3 multiplies everything in here. Immediately occur to you to do that or not. Okay. So that's plus 4. Okay. And we have numbers on both sides. Well, I'm going to take care of the negative 6 here. If I take this and take 6 equals 6, then this 6 is going to go away, leaving us 12x over here. Of course, the 6 has to add with the 4, so we have the 10 over here. Now, does that make sense? The distributive law and multiply everything out, we get an equation that's not that much different than the one we just saw. Except we've got that pesky old 5x on this side. Well, we ultimately want to have our x's over here and our numbers over here. Or we add the equation negative 5x equals negative 5x, which gives us the equation 7x equals 10. And then we divide both sides by 7, then we get x equals 10/7. Okay. Now it's instructive to see what happens to the fractions if we check this. So I'm going to take the time to actually do this check. We get the equation equals 5 multiplied by 10/7. Going to work what's in parentheses to an extent. Now, 4 times 10/7, that's like 4/1 times 10/7. Okay. The distributive law. I'm not going to do the arithmetic of these fractions. I could, it wouldn't be wrong. But it's going to be a little easier if I times 40/7 minus 3 times 2 equals 5 times 10/7 times 40/7. So 3 multiplies the equals 50/7 plus 4. Now we're dealing with an equality here. All we're trying to do is verify that this side equals this side. It would be pretty easy to subtract like 50/7 from both sides and add. Have the thing in this. The easiest thing to do is multiply both sides by 7. So over here, I do 7 times 120/7 minus 6. 7 times the whole thing, 7 times this side equals 7 times this side. Well, that's going to give me 7 times 120/7 minus 7 times 6. Plus 7 times 4. Well, 7 times 120/7. The 7 here will divide this 7, leaving us 120. 7 times 6 is 42. plus 28. And now we just do our arithmetic and we get 78. Okay, because fraction and is a very likely pitfall. Okay, it's very likely to, much more likely to make an error doing that than to know that if you multiply both sides by 7 here, you're going to eliminate the denominators and you're just going to end up with simple numbers. Okay, and we're going to apply that when we get to this one. Okay, so there are various ways of checking it. If all you want to do is make sure you've got the right answer here, you should work out the arithmetic in most cases, but when you're sure that you know how to work out the arithmetic, you punch it into your calculator. I don't necessarily encourage that, but everybody's got time. Yeah. Comes out equal, then you know you did it right. I do recommend that you don't skip the check, because if you skip the check, that's the point off the first time, then you screwed up again, then you've lost almost half your credit. Okay, well, you're not necessarily chasing credit when you're doing the homework. What you're doing is you're trying to understand. Okay, and if you catch yourself in a mistake, it's better than if open math catches you, just because you learn more, not because of points that might not matter that much. Okay. Unless you're pre-calculus course, you're probably going to pass this one automatically. But don't blow this off. Well, you know that. You're smart enough to be in here. Smart enough to be doing the work. And I think you're going to do things. Which is a lot like this problem, so just got more terms in. So I'm going to work it through pretty quickly, and I'm not going to check it, because we don't want to take too much time with that. And the check really doesn't have. You have 4 times 3x plus 4 times 6. And don't skip this step. You can look at it and say, well, that's going to just forget to multiply by 6. If you write this out, you reinforce the distributive law, you reinforce what you're doing, and you're less likely to do something wrong. Next time you have the opportunity, and you know that you always have an opportunity to do something wrong. Okay. So that's just mindlessly writing out the steps of the distributive law. Then we do the multiplications. Of course, it's always possible to mess things up, but it's not all that likely you're going to mess that up. Okay. If you do it in 2 steps, it's likely. So then what do? Negative 24 equals negative 24. And add the two equations. If this equation is true, this equation is certainly true. Now, this equation is going to be true. So you have 12x. I'll leave the 12x as it is. Equals 22x minus 30. Then what are we going? And we're going to get then 12x. No, we're not going to do that. That was just ignorant. I had a pattern going there and I just kept going with it. Like you get to the edge of the cliff and you can both sides. You said something earlier that didn't make any sense. Hopefully we're paying attention. Minus 22x is 0, so we don't have to write it down. Then we've got minus 30, and then we have negative 10x over 10 equals negative 30 over 10. X equals over negative 10. X equals 3. Okay. Yeah, I had no idea that was going to pull up a whole number. We just write numbers down. Make sure 4 times 15 is 60. Okay. That's going to be 15 minus 2, which is so you won't see it as fast. So you might have to write that out. Or if you're really confident, you can write it out correctly, punch it into your calculator. Okay. Okay. So the last one now. Here's something that I have a hard. Easy to solve this. You subtract 7 from both sides. You get x over 7 equals 5. X over 5 equals 5. Then you multiply both sides. Where if you see a denominator in an equation, and not necessarily a denominator inside a set of or two fractions, you multiply both sides by the common denominator. Times 12. It'll give me 5 times x over. Okay. Yeah, that's like 5 over 1 times x over 5. So you have 5x over 5. The 5 still divides the 5. We get x plus 35 equals 60. Subtract 35 from both sides, or subtract, add the equation. Negative 35 equals negative 35, and you get x equals 4. Okay. And that you can check that. And that you can check. Okay. So you can really see that one. over 5 plus 7 equals 12 over. I don't want to use 3. I guess I have to use 7. That's too many 7. So I'm going to change. First thing we see then is a common denominator. Is 5 times 7 or 35. The 5 is going to be dividing the 35, just like 5 was dividing 5 here. And the 7 is going to be dividing 35. It's going to work out. And whether you see that or not, you're going to have 35 times x over 5 plus 8 equals 35 times 12 over 7. Thirty-five times 8. I don't have it. Now remember, I'm doing these arithmetic in my head, but that was a pretty easy one. So I think it's going to work out. Hey, I'm not sure. You know, I don't care if we make a mistake. We get to see how we catch our mistakes. Okay. But since I 35 over 5 times x, because one is 5. Does that make sense? The rule. If you do calculation, make sure you know the rule. And then 35 times 8 is 280. And on this side, you get 60. 35 over 5 is 7x plus equals negative 220. So that 7x over 7 equals negative 220 over 7. And x equals negative 220 over 7. There's no point. So the 7 goes in 21 3 times, okay? And they still have 10 left over, choose your 1 and 3 sevens. Okay, so we can take that and plug it back in. Once we multiply both sides by 5, if we kept the fractions in there. Okay. So that's the first thing you got to understand about. Yeah, that's okay. It's okay. Just do it in this form. You know, don't do this and then write equals 12 minus 7 here and but it was getting confused and kind of scattered over the paper instead of being in nice coherent form so you can see what you did. Okay. So make sure you do it in this form. so you can see what you're doing. No, tomorrow. So roads might be okay the following morning, but if the snow materializes when it's supposed to, I would suppose that we're probably going to be closed down because it's supposed to start. Be an amount of snow that if we knew in advance. And then having to drive off the hill on ice. Okay, even though I think we've got plenty of salt, we can take care of it. Yeah. It'd be a liability, we get sued. But better than usual, and much colder than usual in January. There's a good. Once you refresh yourself on this stuff, this is going to be pretty easy. I don't think you're going to have any trouble because I'll do your work. If you can get into open math. So make sure you take care of that one way or the other. If you can't, email me with it. Because I can email Jason. Okay, now. No. Okay. And you know that 150-pound person needs 48 milligrams of, I don't know, whiskey. Okay. You had it when you had your surgery, appendectomy, and you wake up and pretty much feel. Yeah, I had cardiac bypass surgery about 11 years ago. Had a heart attack. And you know, they got to it quickly. The only damage is that I've got to take some medication that. Okay, you're good. Go home. I said, well, should I worry about steps? Should I worry about this? No. Heart's fixed. If your body can do it, your heart can have. Uh, it's pretty good. Now I get off on that. I was just going to make the comment that you think cardiac bypass surgery would be painful. Yeah, I mean, they split your chest open, contract your ribs and stuff like that. I had no pain whatsoever. They glue your chest back together with super glue. Okay. And your ribs are sore. Well, I played football, not particularly well, but I played football and I'm experienced with sore ribs. You just don't breathe very deeply for a day, and the next day it's much better, and the next day, right? So that's just the anesthetics we got right now are really neat. Okay, so you know that 150 pound, 150 pound person, how much you give them? Okay, you give them more, you give them twice as much. Okay. Just outpatient, like, you know, you go home 3 hours afterwards, not bad. The anesthesiologist didn't give her quite enough stuff. And apparently she moved a little bit during the surgery and that punctured the lung. Okay. Well, and she's a nurse practitioner, my wife is. And the guy apologized to her, and, you know, she was okay with it. And she refused because it would kill her. She, the resident didn't. It's good to know something. Now, all that's digression. Okay, but it's it's more complicated than just weight, incidentally. You gotta consider muscle mass and fat mass. Stuff probably perfuses differently in different tissues. It'll perfuse into your muscles in a different way than it does into your fat. So I don't know if fat requires more or less, or if it really doesn't matter. So anyhow, yeah, it's gonna kind of perfuse equally everywhere, and really you're trying to perfuse it into the brain. Okay. All right. But the, now the proportional to weight, we're gonna let y be the amount, we're gonna let x be the weight. We want to find K. Anybody got an idea of how we can take this information and find K? If you do, let me know and we'll pause and talk. Okay, somebody's making some gestures here. I want to see what the heck they mean. Rate of change, okay? And actually, we're gonna get an average rate of change when we find K. So far from something that's important for this situation. Matter of fact, we'll even see what it is, okay? But right now, it's simpler than that. Value of X. Okay, write down Y equals KX, but substitute. Okay, good. And I'm gonna write the milligrams, 48 milligrams. It's optional. Until we get. Yeah, that comes. Well, I think it would be a good idea. Because it tells you, it puts a meaning on these quantities. Okay, so that tells us that K. Well, that's 0.32 milligrams per pound. Okay. This is called well, now we can write down. I say Y plus KX now reads. X. I'll use parentheses here. To a milligram. And let's see, 200 times 0.32 is going to be. So not only did this work, okay, makes sense? Okay, well, there's more, and you're going to see it in the exercise. Now, there are other proportionalities, and open math will explain some of those. Sometimes In other cases, you have like y equals k times x squared. X squared. Well, guess what? Y equals kx squared. That's your squaring rate. With y equals k over x do. You do. Okay. So this one, which you ought to be familiar with, it was in the first assignment in open math. Okay. And there's a connection. And there's the slope. That connects to the stuff that I have. Open math is not going to make a lot of those connections. They're going to teach you how to use this procedure. Okay, but get good at it because it's very important. And even ask it. Prep schools, okay? It's a public school, have the